It's frozen on my end. Okay, here we go. Hello, everyone. Welcome. It's Jackson today, as always, on this channel, because it's under my name. But I'm also on with Inspiring Philosophy. So hello, Inspiring Philosophy.
Hey, yeah, thanks.
Who goes by Mike.
Yep, you can call me Mike. Mike.
How are you doing today?
I'm doing pretty good. How are you doing?
Well, I'm all right. I'm very excited for this. I've been thinking a lot about this chat in particular over the past few weeks. Been talking to Savannah a lot about it. She's I've been doing a lot of thinking on it because this is an area that I am particularly interested in because I'm going into the field of evolutionary biology as my career.
Nice.
Not sure if I'm going to specialize in zoology or evolutionary biology as yet. I'm getting my bachelor's in field and organismal biology right now, so once that gets done, then we'll see. Where do we go next?
Yeah, that sounds like it's going to take a lot of years.
Yeah, it's going to take the rest of my life. But regardless, I bumped into this whole, for anyone, I guess we should put it in perspective first for anyone who's not aware, hasn't seen my videos, yours. I was asked by Mr. Brass on Twitter. I'm not sure if you're familiar with him.
Yeah, he
Brass
talks
Wisdom.
a lot. He always is sending me stuff. So yeah, he's always like, look at this. I'm like, okay, I'm busy, but okay.
Well, he asked me one day if I would classify myself as a Neo-Darwinist, and I hate labeling myself in general. There are a few labels I'm fine with, like I'm fine. I'm an atheist, or some people say evolutionist. I don't like the term, but I understand the usage of it. I really hate when people say Darwinist because no one's a Darwinist today. But he sent me your video, and I was intrigued by it, and so I watched that. And I had literally never heard of structuralism.
Really?
And this was just like 2 months ago, I think. Yeah, I've been reading literature on evolutionary biology for several years now. The term has just never, in this capacity, I've heard of it in English, the structuralist and post-structuralist, but I've never heard of structuralism being applied to evolutionary biology. And so this was my very first foray into it. This was a completely new area for me, interestingly enough.
Yeah, it's what kind of got me into it was I was debating creationists, and it got me then focused into evolutionary developmental biology because they were talking about genes, and so that kind of got me there. And then from there, from studying a little bit of Evo-Devo, I then found my way into the larger structuralist paradigm. And then I got really excited about it. So I read so much, as much as I could on the topic, like different papers and books and whatnot. And so yeah, that's kind of how I got into it. It was just the whole issue kind of excited me, mainly from it. I thought it solved a lot of the, I thought it gave more strength to evolutionary theory when dealing, especially with creationists, how it's focuses on positive constraints and internal constraints and tries to develop an extended theory of evolution. And so that's kind of how I got into it. And then, of course, as you know, I did a couple of videos. I did 2 videos on it where I talk a lot about the data. Basically, both videos were trying to get Christians more warmed up to the idea that evolution is okay. Calm down, everybody. It's not a problem. And so that's kind of how I got into it.
Oh, yeah. And we need more people like you, more people like Cygart, because he's in the chat. Hi, Cy. Hi, Beach. Hi, everyone. Welcome. Yeah, we need way more people who are doing this. I mean, look at BioLogos. I think it's a great source. I think it's critically undervalued in a lot of these conversations. People usually turn to Talk Origins, which is a good source. But I think BioLogos also has a lot of really smart people writing for it, putting out these really good arguments because a lot of them, either came from creationist backgrounds or they understand the mindset. Whereas Talk Origins is just like, well, here's the argument, here's the rebuttal,
Yeah, I like Talk Origins though. There's a lot of what I like about them is that they give a lot of the studies like right then and there, so I can just check it really quickly instead of having to, try to fiddle around. Because I hate when I get a source and it's like, I'm going to quote this guy and they don't give a source, so I have to go Google the quote and see where the source is. But Talk Origins is pretty good. I can just get it right there.
Yeah. Yeah, and when I was listening to your talk with Invoking Theism, and you were like, oh, you know, when you hear this argument, there's this rebuttal to this, and there's that, and that is great. I did watch your debate with Hovind. Good Lord,
Yeah.
I also had a debate with Hovind.
I liked your debate with Standing for Truth, though. I thought you did a good job dealing with a lot of his misconceptions. My favorite part was when you were like, when you came time for your rebuttal, you're like, well, I already prepared a rebuttal because I knew he wouldn't be able to answer this.
Yeah, and that was with Rational Mind and Nestlig. I know Nestlig's in the chat. Hi, Nestlig. And RJ Downard. He's great. They're all great. And they helped me write my scripts for my videos.
Oh, man.
And so I had already had 2 talks with Standing, and they are sadistic. They listen to his videos just for fun. But amongst all of us, we knew all of his talking points. We knew every argument he was going to throw out. We knew he was going to make the H1N1 argument and the rust on the car analogy. He always uses that one. And so it was like when Matt Dillahunty did his rebuttal for his debate with Seitan Bergenkate. You know, if you already know all your opponent's points, just it makes it look so much better if you already have it written in advance.
Yeah.
You know? But yeah, it was a hoot and a half. But anyways, so this conversation in particular. Oh yes, for anyone who is wondering, we both already agree on evolution. IP is not a creationist. Everyone's an evolutionist here. We're all good.
Yeah, we're all good.
So Mr. Brass sent me the video. I watched it. That it was intriguing. I did mine because the structuralism is more about the internal physical constraints, right? How tissues self-organize and how atoms and molecules self-organize, right?
That's an aspect of it. One of the things that you'll know if you read a lot of the structuralist literature is that they try to, it's more of like an extended evolutionary theory. So if you read someone like Simon Conway Morris, he's going to put more emphasis on positive constraints, external positive constraints. Michael Denton, for example, is going to focus more on internal constraints, or someone like Stephen Jay Gould also spends a lot of time on Evo-Devo and internalist constraints as well. So, and then of course there's also internal disagreements between structuralists, like Stephen Jay Gould and Conway Morris had an interesting debate about the Cambrian explosion back in like 1998. So basically a lot of what structuralists are doing is we're not against Neo-Darwinism. Like I was just listening to a talk the other day by a Professor Dennis Noble, and he tried to emphasize numerous times in his talk that like I'm not against.
I think I know what talk you're referring to.
The Dance to the Tune of Life lecture.
I think I think that one's been copied in a bunch of different ones. That lecture has been copied and distributed under a whole bunch of different names, but I do believe I know which one you're talking about.
Yeah. I mean, he says numerous times like he's not against neo-Darwinian mechanisms. He's not against the idea that mutations are random, but he's just arguing for an extended theory with more areas of constraint. And so that's kind of what structuralists are getting at. Now, when we do that, though, the major disagreement, though, is we're arguing that although there is contingency that is involved in the theory of evolution, that there are also positive constraints that are causing not so much like, I don't know if intentionality is not the right word, but like a directional course. And so the analogy I give is the periodic table. If you knew all the laws of physics prior to star formation, you could potentially predict that stars would eventually produce the variety of different elements on the periodic table. You know, eventually you could understand the physics of supernovas would compress and different elements and cause things like uranium. So you could see there's kind of a direction to get this plethora of different elements. And so structuralists kind of follow that kind of similar type of logic, is that we say, there is contingency, there is definitely randomness involved, but ultimately it does arrive at some certain types of solutions, different types of, or different aspects of forms or life and whatnot.
Okay. So I would not necessarily agree with that. and here and my the and again, I've never heard of either structuralism or functionalism. I just never heard those terms before about 2 months ago. Because when I read the literature, they're just like, okay, here's this mechanism for why these organisms have this, this structure, why they have this one. No one's ever saying, okay, well, under the functionalist, perspective, this is why they have this. And so I just never heard of that before.
You gotta read like Rudolf Raff or Stephen Jay Gould's book, because Gould uses functionalist, structuralist, functional. He uses that all the time in his when he's going through the different chapters. And so it depends on who you're reading, really. I mean, in my video on structuralism, the big video I did, I kind of simplified a lot of stuff. So when I talked about the section on convergence, I really just kind of generalized, because really, if you look into like, the literature, there's different types of the convergence. There is like homoplastic convergence, or there's parallelism from underlying homology. And I just kind of like, well, I don't really have a lot of, I don't want to overload people too much. So I just kind of generalize a little too much. But if you get into the literature, there's a lot more complicated ways of describing it.
Right. Yeah. I did read a little bit of it. I mean, I'm familiar with Gould's work, like A Wonderful Life, but one of the structuralists I read was Gerd Muller, I think was his name.
Oh yeah, Gerd
Talking
Muller.
About how the Precambrian organisms were pre-Mendelian systems, which I was like, ooh, that adds a lot of interesting assumptions. I mean, it could. I'm not entirely sure how one would. I guess theoretically you could potentially demonstrate that to be correct, but I think it involves a lot of extra assumptions that aren't needed. Like we know, like we can identify modern phyla in the Precambrian. Like we can identify bilaterians. Some even like a Cambarella might even be a mollusk. There's heavy debate on that, but it's at least a Lophotrochozoan. So, it's like, is there any reason to believe that it's pre-genetic? Not really. Now, I do want to say, I do absolutely agree with you when you were talking about well, I say absolutely agree. I agree with you the most when you're talking about abiogenesis.
Okay.
Although I have to say, even there, you outpaced me, because
I'm quite hopeful. But yeah, like someone like Sigart, like we were talking the other day, and he likes to crush my dreams on. Yeah, I think honestly though, I think I am quite hopeful that there will be a lot of like self-assembly explanations involved in abiogenesis. So yeah, that's something I disagree with like Simon Conway Morris on, where he's more like it's extremely hard to get past that point, whereas I'm more like, well, maybe not. And there's hints of that now, but I mean, again, it's still underwhelming compared to the evidence we would need.
Sure. I've done a few videos on abiogenesis. I did two, which was, one was abiogenesis part 1, which is basically just explaining what abiogenesis is. Then abiogenesis part 2 was an explanation of abiogenesis based on the book The Vital Question by Nick Lane, which is a fascinating book. Mm-hmm. He talks about how you have like these hydrothermal alkaline vents, and they're generating these necessary molecules, and you're going to get phospholipids to arrange in micelles because they have the hydrophilic heads and hydrophobic tails, and then if you get RNA in there, you've got all these different processes, all these different biochemical and geochemical processes which are going on at once, which could potentially generate life. And I think that's a good explanation. I think I do probably think it's hard to get life. I mean, your video is, like that life is inevitable. Mm-hmm. And I was like, it's kind of weird to be outpaced on acknowledgement of abiogenesis by a theist, I have to say.
I'm proud to do it. I'm really excited by it. I just actually read a paper you might be interested in. It's compositional genomes, prebiotic information transfer, and mutually catalyst non-covalent assemblies. And they argue there's a lot of, it's a very interesting little short paper they did. They ran these different computer simulations on prebiotic different molecules enacting in very complicated behaviors, I guess might be the word to put it, can result in this early thing. So like, here, I'll just quote from it so I don't butcher it. They say spontaneous growth and splitting of assemblies results in complex population behaviors. So this is before, genes, before DNA, but they're still getting very complicated behaviors in this like prebiotic soup type thing. But it's a very interesting little paper.
Yeah. Abiogenesis research is very interesting. When I did the video, what was it? Creationist statistics, because I was the intelligent design camp, of which Michael Denton is a part. A lot of them really don't like abiogenesis.
I don't get that. I don't know why he's part of that one group. He's not even. He's an agnostic.
Yeah, it's very curious in that respect.
I mean, to be fair, in his books, he does say evolution happened. He's just like very extreme structuralist. He's like almost like Darcy Thompson structuralist, like very much to that end.
Well, sure. The thing about intelligent designers is functionally they say, or a lot of them say, what a lot of them say? Okay, well, they are able to say that the Earth is billions of years old, life is billions of years old, shares a common ancestor. Michael Behe does actually do that in Darwin's Black Box. He does go out and say that. The problem is where the rubber meets the road. Okay, if everything shares a common ancestor, whence cometh the design events? How many design events were there? That sort of thing. Like, okay, if the flagella is not creatable through natural selection, and you think it took a design event, was it one? Was it a few? At what point? And it's as RJ likes to say, it's Tortugan. They're not thinking about these sorts of things, these what I think are fairly important aspects of their idea. But I was taking aim specifically at Stephen Meyer in that video because he wrote Signature in the Cell, which has part about arguing abiogenesis isn't possible because getting proteins is too hard. It ignores chemistry entirely, but
it's like I talked about it in a little bit in my video originally. Was like a lot of like the protein folds have been shown to be the result of a lot of self-assembly. So it's not like, I mean, sure, that's not proteins directly, but I mean, there is self-assembly processes already at play in there. So it may not be as hard as a lot of intelligent design advocates are claiming. And so I don't know why they keep harkening on about that. I think they're just shooting themselves in the foot ultimately.
For them, it's like for Signature in the Cell, he argues basically you would get random amino acids every time. It's like, no, you don't. That's not how chemistry works. You don't just get random amino acids. But yeah, I did a whole video about that. It was all fun stuff. But we have a question from the audience, and this is one that I guess at some point I was going to ask, but I guess it's a good time to ask. This is from Nestle. Assuming aliens exist that are at least as intelligent and technologically advanced as us, what specific or general details do you expect from their body plan?
That's a good question, and I honestly am not too set on it being like necessarily humanoid. So I remember I was reading Simon Conway Morris on this, and he was like, if you rewind the tape of life, you might get hominid-like creatures again, but it could come from maybe like a squirrel type line, or it could come from like a South African primate line, or you could get something that's not even looks like a bipedal ape. You could get like a corvid type creature, or you could get something else. So I'm not so necessarily nailed down to the idea that if there are aliens out there on other planets, they're going to look exactly like us. But I do think you'll get some sort of basic sort of like idea with like maybe like a tetrapod type idea where you definitely have 4 limbs, but more or less I'm more focusing on the idea of sentience or intelligence getting to a certain point at somewhere. So Simon Conway Morris sometimes has been taken a little bit out of context in it, thinking he's advocating that every time you rewind the tape of life, you're going to get
the exact same. Right.
Exactly Homo sapiens. And that's just not his argument. His main argument is that you will eventually get to the level of intelligence that we have.
Maybe one of the papers that you mentioned in the blog post response to my response to your response, or to your video, was a paper on these guys predicting what features aliens or we should at least expect aliens to have. And one of them was we should expect natural selection to happen. And I was like, okay, fine. They said we could probably expect multicellularity, and I was like, okay, fine. Sure, some of these things are. Multicellularity has evolved like 50 different times, and I think that's an underestimate, probably.
Yeah. The same with what is it? Air breathing is evolved, I think, 38 times. Jeffrey Graham has noted it evolved like 38 times, and it could have evolved even like 60 times.
Oh, that's just in modern phyla, really. We have no idea. Like, what the heck are the Ediacarans? Are they animals? Are they protists? Who knows? They could be independently multicellular protists, and I would really hate that, because then we'd have no idea where to put them on the tree of life. But he said, Nestle says he would disagree with the four limbs. I think I would. I think I would too. One of the things I talked about in my video was when you look at like the arthropod bioplan, for instance, you've got the head, the abdomen, the thorax. Mm-hmm. Well, when you look at its close relatives, the tardigrades, the water bears, and the onychophorans, or the velvet worms, all of these guys they're kind of built around the same thing, but you've got mutations that are changing. For instance, the tardigrades lost their body segment, so they're really compressed, whereas the velvet worms are really much elongated. Then you've got and then you've got the arthropods. But the thing with it is it's mutations, and mutations are going to be contingent, right? Because mutations are random by definition, or pretty random.
See, this is where I think some of the debate will come in, because yes, mutations are random, but there are still certain processes that would be constraining it. So this is something Dennis Noble has noted in some of his work, is that what he argues is that, yeah, mutations are random, but basically the targeting of what an organism does through, for example, stochasticity is to achieve like certain types of results. So it can rely on these sort of stochastic processes, which create various sorts of mutations. But ultimately, though, it's using that process, in his words, to sort of generate this sort of directional type result. So, yeah, there is definitely a lot of contingency in there. The question is does that cover all of it, or does it play a part in a larger picture? And that's one of the things they're talking away on his website, the third way of evolution. That's what it's called.
And again, I would agree with you, because for anyone wondering, it's not like we didn't come on here to be like, all right, let's butt heads over this. We agree on most of this stuff. There's really a rather small portion of what it is we disagree on, because we don't disagree on evolution. We don't disagree about abiogenesis happened. It's really the mode, the structure of the theory of evolution itself. And so, yeah, again, I would agree when I say that there are certain physical constraints. There are certain structuralist interpretations that are necessary and do explain things well, like Turing mechanisms obviously exist. We can show that certain organisms display Turing mechanisms. Physical constraints definitely constrain cell size. Like a cell can only have a certain volume to surface area ratio before it's unable to function. So I would definitely agree that there are what is there, like the square cube law? Isn't that another one where it's like organisms can only be so large or whatever? I think.
Yeah.
Like that.
I think I remember Morris talking about that in Life Solution, because he was positing why don't we have. I think he specifically was positing why don't we have large flying mammals, just as sort of like a tongue-in-cheek example, like really large, like the size of like a whale, basically.
Yeah. But I wouldn't. And I would agree that there are physical constraints governing parts of evolution, like gravity and things like that. But I wouldn't say that those necessarily would cause vertebrates, for instance, or arthropods, or even those sorts of body plans to rise on a different planet because of the randomness of mutations.
Right. I think that's one of the main differences, is that a typical someone who leans more towards like the functionalist side would note negative constraints. So that's why, like, zebras can't just fly wings. It's just not, it's a negative constraint within the environment that prevents them from going down certain paths. And so a negative constraint you can kind of picture as like a box. If you put an organism in a box, it can do a lot of different things in the box, but it couldn't, get bigger than the box, so to speak. So it's a negative constraint. It prevents the organism from going certain ways. Whereas like a positive constraint is something that might be a promoter, a supplier, a cause. And so, for example, Thomas Hansen would define it basically as this: an important element in the modern treatment of constraints is that constraints are not just seen as limitations and explanations of a last resort, but also assign positive explanatory roles based on channeling variations and directions that may facilitate and explain adaptation. So like a positive constraint, in other words, is just something that almost would push an organism along a certain path to sort of arrive at a certain conclusion. And so Gould spends a hell of a lot of time in his book arguing for different positive constraints that are sort of guiding different clades down different trajectories or different channels, so to speak. So, if we distinguish between the negative and the positive, I mean, I would agree with you. There clearly are negative constraints, but then what a lot of people on the structuralist side do is we try to emphasize, but there are also positive constraints as well.
Sure, I would agree with that. I think there are probably different positive constraints out there. But if I were looking at, say, the Cambrian Explosion, for instance, I don't really know how a structuralist would explain that, because what you see is this huge radiation in forms.
Mm-hmm.
And it's rather easy to explain that without invoking a lot of like assumptions about the environment or about how their body systems work, by pointing out that, okay, this is a period where you've got oxygen increase, you've got an increase in predation, you've got and you've always got mutations, and so you've got arms races driving the proliferation of organisms with hard parts like arthropods. That's why there are so many different arthropods and stem arthropods and things like that. You've got this whole ecosystem where you've got arms races and all these sorts of things. And so you're going to capitalize on various mutations, which are, again, historically contingent, which is going to drive the evolution of these different groups. So you've got selective pressures and you've got variability, and that's what's going to drive them. And when I look at the technical literature, as I was doing on Protist just the other day, that's really how they explain these things. Like I said, sure, some things are explained in terms of, well, you got the physics of this, which is, preventing this, or it's causing them, they have to evolve in a certain way. But still, they're explaining it in terms of mutations followed by selective pressures, which are pushing them in different directions.
Right. And it was, so a really good, interesting read on that would actually be between Simon Conway Morris and Stephen Jay Gould back in like 1998. They had a little conversation on the whole thing. And then, interestingly enough, when Gould wrote his massive book a couple years later, he was a little bit more sympathetic to Morris's ideas. And I think Morris did kind of respond to some of this, unfortunately, after Gould passed away. So we don't really get Gould's response, unfortunately. But yeah, I agree. There are, as you kind of said, there are these different trajectories that the organisms are kind of being pushed on. He talks a little bit more about this in this massive book of his, The Runes of Evolution, a huge book. I think it's better than his other book, Life Solutions. But he notes there are several repeating patterns within that specific phase as well. There are occurrences of parallel evolution, even going back to early like protozoan or metazoans. And then he cites a whole bunch of other different papers noting that when you start to get into like the nitty gritty of these things, you can definitely see that there is positive constraints even happening there. And there's a whole mess of different papers he goes over and whatnot. So I think what we basically say is we're like, well, yeah, we do agree that, there is constraints in that area, and there are different forces that are going to force evolution in certain ways.
Mm-hmm. Yeah, convergence issue is one of the primary things I kind of thought about when I made my video was, and it's yes, there are convergences, yes, they're rampant, but at the same time, they're driven by historically contingent mutations followed by selective pressures within environments, right? Like I mentioned the like New World porcupines and Plotarines, the New World monkeys. They both have prehensile tails, but because they had historically contingent mutations that opened up specific potential adaptive pathways, and they happen to live in these environments where certain pathways were realized. But all of that seems to, or I should say, none of that really seems to get me towards the structuralist interpretation. Really, that all seems to bear more towards the functionalist interpretation.
How can I ask how so though? Like, how would that work with that?
Well, I guess the pure functionalist interpretation from what I saw of Gould and of Denton is pan-adaptationism, which nobody holds to today.
Yeah.
When I saw Denton say, "Oh, the vast majority of evolutionary biologists are pan-adaptationists," in 2013, I was like, "The what?"
Yeah. That's why I said, like, in the past, like, Denton is kind of like hit or miss sometimes. I really like some of the stuff he goes over, but sometimes I'm just like, that's just not right. Like, that's just wrong.
Yeah. Yeah, I have that sometimes with some of the people. But so functionalism is more stressing the historically contingent nature of things, and it's only happening this way because they were in a certain environment at a certain time, and they had certain mutations, which is what caused them to go along this path.
Mm-hmm.
But structuralists wouldn't really say that, right? Well, as far as I understand it.
Well, it depends on who you read, I guess. I mean, when we look at the reason why Simon Conway Morris has written so much on convergence, I mean, like literally, like this book alone is like most of like new examples, like that he doesn't even repeat in Life Solution. So he's just trying to like find more. But the reason why he harkens so much on this is because if for the same reason I gave earlier, and then when I talked about how like, we could possibly predict the production of uranium. If you put the same elements in a supernova, every time you're going to get uranium because the laws of physics sort of constrain to bring about a certain result. And his point is, now just take the same kind of underlying principles you get in biology. If you put an organism in a very similar ecological niche, there are going to be positive constraints, which are going to sort of cause organisms to converge along a similar path because they're both trying to fit in the same sort of ecological niche. So, I mean, like, when I first heard about a lot of the examples of convergence, it was actually from more structuralists, like Stephen Jay Gould and Rudolf Raff. Raff focuses a lot more on Evo-Devo, but a lot of the authors of this book as well also go over a lot of examples of convergence, because to them, they're arguing that, well, look, this does show evidence of positive constraints, that evolution is sort of constrained along certain paths. Anytime an organism will enter a certain ecological niche, we should expect to see very similar results, and that's why we see so much convergence. So I don't think when I look at convergence, I don't say, no, you're wrong, it doesn't work within a functionalist paradigm, because structuralists are not really much opposed to a lot of the ideas in functionalism. We just say, but in the bigger picture of things, it does sort of show a little bit of trajectories being formed.
Well, and here's how I would say that when you do enter in certain ecological niches, it makes sense to have certain features, right? But also a lot of times you have animals who don't have these certain features who do quite well in these environments. Like if we go back to the arboreal example, yes, there are lots of animals with prehensile tails like Plotarines and New World porcupines, but squirrels don't have prehensile tails, and they are incredibly speciose, probably maybe even more than both Plotarines and New World porcupines. And so, yeah, I mean, it makes sense to develop these sorts of things, but I don't know why the structuralist interpretation would necessarily predict those, because from my understanding of Denton, he's trying to more explain the body plans. He's trying to explain why are there phyla that look like this. Why do we have arthropods? And why do we have arthropods? Why do we have vertebrates? And so when I listen to or when we talk about convergent evolution, I kind of think, okay, well, how is this really helping the structuralist view. I don't really understand what the cellular mechanism is for generating these sorts of forms like prehensile tails in these different guys, but not in others like squirrels. It just seems to make more sense that you have historical contingencies which open up historically contingent potential adaptive pathways, and that's why we have prehensile tails in this group of mammals, but not prehensile tails in this group of mammals. And that's my major kind of point with regard to that.
Well, I think one of the reasons is because of the constant repeating. So I mentioned earlier the fact that, Jeffrey Graham notes air breathing has evolved like 38 times independently and maybe up to like 67 times. Now, if it had evolved like 5 times, I might be able to see, okay, that's kind of odd, but so many times it kind of seems like nature is kind of constraining and trying to force certain trajectories. So it's not, structuralists don't just focus on internal constraints like you see in evolutionary developmental biology, like from Hox genes. They also focus on sort of positive constraints in the environment that are going to force organisms to converge in similar ways. Now, you're right that we're not going to get exactly the same thing exactly every time, like with the example of the squirrel, because, it's unlike within a supernova, biological environments can be quite diverse. And of course, complicated organisms are always going to vary. So we don't look at the historical contingency and go, well, that just can't happen at all. I mean,
well, I'd say you're not a structuralist then.
well, that's the thing, though. But structuralism is not so much. I mean, there are very extreme versions like Darcy Thompson.
Oh, sure.
But I mean, it's not so much one or the other. It is a spectrum. And I think the real disagreement you and I would probably have is more like, well, what is primary? Is structure primary and then function like secondary, or is function primary and structure secondary? So
can you rephrase that for me?
Sure. So what is going to be, how do I rephrase this? So what is going to be the main thing that is going to be driving evolution? Is it going to be some sort of contingency where it's just whatever sort of function we need, we're just going to get it? Or is it going to be more like, well, we're building certain types of structures that are sort of just being constrained by evolution, and then functions to sort of come out of there? So one example I remember you mentioned in your video, you mentioned the chin. It's a structuralist thing. It doesn't really serve some sort of very adaptive advantage because Neanderthals didn't have chins. Hint, creationists, they're not humans. But you can, for example, find functionalist uses from a chin and whatnot. So a good example might be like, for example, my house. Okay, so the walls are part of the structure, but I could find functional uses out of the walls, like, for example, hanging bookshelves on or leaning against, for example. So
that sounds like exaptation.
What?
That sounds like exaptation is what you're referring to. Maybe,
but I'm more trying to just differentiate primacy here. So what would be primary? Is structure going to be primary, or is function going to be primary? And with structuralists, well, more people that move towards the structuralist side would say what we see in the extended theory of evolution is there's more a building of structures, and then functions sort of are a secondary addition onto that type of thing.
Well, I think I can give you a real world example of what you're talking about, and it's feathers. I'm not sure if did you bring? Yeah, because feathers didn't evolve. Feathers didn't evolve for flight originally. The first animals to possess feathers were earthbound archosaurs. Things like Microraptor and all these little dinosaurs who were not capable of flight. At least so we think. It would be interesting to find out if they were secondarily flightless, but that's a topic for another time. Anyways, but yeah, you have. Why don't we know tyrannosaurs weren't capable of flight? But you have a bunch of different dinosaurs, mostly theropods, although there are a few ornithischians, but they have feathers. And then the first birds, or what we identify as birds, have feathers, and they hone these things. Like it's kind of like you can hang stuff on the wall. They already had this wall, and then they hung something on it. They hung flight on it. They hone the feathers until you get your like one type of feather, then you get panaceous feathers, and then you get flight feathers at the very end, right when you get the birds.
Right.
And they're very close cousins. And so but that'd be exaptation. So.
I kind of get what you're seeing out there. I mean, I'm not so sure. I might even go more towards the functionalist side on that maybe feathers originally came out for a certain function. That would be
for like heat, warmth, and sexual display, maybe.
Yeah, I think I do remember reading. I can't remember who it was, but I do remember reading something with regards to that. So yeah, that would be interesting. But getting back to the main point, that's kind of what I was getting at, is like, what is evolution trying to do, though? Is it trying to stick to certain forms, or is it trying to just find functions for different ecological niches? And so what structuralists do is we kind of say, well, why can't it be both? Why can't
I would agree with you, but I wouldn't call myself a structuralist.
Well, see, this is what I think when we start getting to the nitty gritty of this, when it comes to like functionalists and structuralists, there's not that much disagreement. Our real fight is with like creationists. People just deny evolution. But like when you get to like the little things like this, it is more just kind of like semantics half the time. You know, you and I would probably end up agreeing on a lot of things. The point of my video was Life Inevitable, was just trying to talk about how a lot of new mechanisms or a lot of new constraints that are being understood in evolution might start pointing towards the idea that life is sort of just following along certain trajectories. And like one of the papers I cited was written by two chemists, where they talked about how life was in a tunnel and it was just going along a certain trajectory that it could not just avoid. So if that's the case, though, I think it just gets back to one of my original points. One of the reasons I kind of got into structural is because I thought it explained evolution better, in that it kind of points to sort of natural laws sort of just bringing about certain organisms, which gets away from a lot of the arguments that creationists tend to throw, like, well, how could this come about from random chance? Or how could that have come about from random chance? Well, maybe it wasn't random chance, as a lot of the evidence is sort of building up, is that maybe it was, if you understood all the laws of physics 500 million years ago, you could predict certain forms to come about. And that's mainly what structuralists are trying to get at. We're trying to note that it's almost predictable to a degree. I mean, there's going to be a little contingency in there, obviously.
Well, that's precisely where I disagree. But if I were to say it's in a tunnel, it's an extremely, extremely large tunnel, only really constrained by the mutations that are going to cause that are going to be fatal, and perhaps anything that doesn't really work in nature or would go against the laws of physics. But really, that's the only sort of out of bounds, I would say.
I think
I wouldn't say
tunnel is.
I wouldn't say, for instance, that we should expect the arthropod body plan on Mars, for instance. I wouldn't expect that at all, because arthropods came out of an event where you have, like I was saying, you have arms races, which drive in the evolution of tough body parts. You have an increase in oxygen. You have all these different factors, like chemical weathering the continents and all sorts of different things. I've done like 2 videos about it. There's a lot of stuff going on right at the boundary of the Cambrian, and so so when taking all those sorts of things in, it's like, why do you have, we've got these Ediacarans who may or may not be the springboard for the later metazoans. There's chemical weathering, there's increase in oxygen, there's arms races, there's eyes coming in, which are just starting to pop into existence, as far as we know. And so it's like, well, when you put all of these contingent factors together, I don't see any reason why we should expect the arthropod body plan or the vertebrate body plan to result from that. And that is my position.
I think we should then talk a little bit about Evo-Devo, because this is one of the things Steve Jay Gould gets a lot into his book. He talks about Hox genes and how a lot of the ground plans for vertebrates, arthropods, cephalopods was sort of already in the developmental pathways within homology 500 million years ago. And so this idea of this deep homology that is still sort of guiding evolution, or still involved in evolution, he kind of goes on extensively and cites numerous studies from, like, E.M. Robertaris or Manek and Scott's, on how a lot of this stuff is almost sort of being guided along with the different processes we see within Evo-Devo.
Have you read Neil Shubin, for instance, Your Inner Fish?
Mm-hmm. I think I've not read the whole thing, but I remember reading him when I was prepping for the video.
Neil Shubin would not, as far as I understand his work, because I've read a few technical papers by him, he's very much on the contingency side, at least from what I've read. I'm not saying that he is totally against structuralism. No, obviously not. None of the no one should be, at least, because it has merits, obviously, as we've discussed. But for instance, when you talk about the arthropod, the tetrapod limbs, for instance, why do we have these? Well, fingers, for instance, were novel structures. Our fingers did not result from the fin rays of the fish that we're descended from. They are novel structures. But when we first start out, the first tetrapods we find had 8. They had 8 fingers, right? And then it went down to 7, and then 6, and then the first pentadactyls were around by like 350 million years ago. So like the Carboniferous. But it all seems like it's you have contingency and you have selective pressure, which are pentadactyl. I mean, it stayed around. It has it's in all of the modern tetrapods, except for the ones who have lost digits, but none seem to have gained digits. So clearly it has selective advantage. But would I say that means that it's going to come about? No. Maybe there was some point where it was necessary, and then it's still necessary to this day, but I'm not sure if I would say that we could predict pentadactyl animals on a different planet, for instance.
Well, I mean, Shubin kind of goes into a lot of this stuff, and I mean, I remember citing him in my video. I mean, he talks about how the great evolutionary transformation from fish to fins did not involve like new DNA. It involved just modifying this old DNA. That's one of the big things I was citing him.
Well, I mean, that's all evolution. You never get new DNA.
Well, I mean, obviously, but I mean, one of the problems though with that was that the original modern synthesis was predicted that DNA would constantly be molded and molded and molded, so that 500-year-old Hox genes, 500-year-old Hox genes were not supposed to be around. 500 million-year-old Hox genes, were not supposed to be around. And so, but that underlying idea. So this is what I go back to the point about what is primary, structure or function. Obviously, yeah, there's going to be variation. I mean, structuralists don't deny that. What we're talking about, though, is if you have those underlying Hox genes, if you have those underlying guiding principles, those underlying structures that are sort of still there, still present, then it's not so much anti-function. It's just pointing that, yeah, function is still a major important part, but it's secondary. So like, for example, Rudolf Raff says, internal factors constrain evolution. So no, he says, sorry, yet if internal factors constrain evolution, they are hardly a minor issue. The acceptance of internal constraints does not mean that Darwinian selection is unimportant, but it just basically means it's sort of relevated to kind of like the side. It's going to create, different amounts of fingers, as you mentioned, but it's ultimately going to be building on these underlying structures, and then different organisms are just going to have to sort of mold to different sort of ecological niches to sort of as they need.
Well, I mean, that's kind of general. In that sense, it seems that almost, I mean, that's really just what evolution says. I wouldn't even say that that's structuralist. I would just say that that's just what evolutionary theory says. You have to work with what you have. You're dealt a single hand of cards. You can't add cards unless, through mutations or whatever. But again, I'm not sure if I'd call that structuralist necessarily, because going back to the arthropod example, when you look at the tardigrades and the onychophorans and the arthropods, they're all built. You have the same you have all the same Hox genes, which are operating in these guys. Of course, you have a lot of their same Hox genes in us too. But in tardigrades, they had mutation where they chopped out some. In onychophorans, they duplicated some. And then within the arthropods, you've got loads of different ways to arrange those Hox genes. You could be a coleopteran, beetles, or chelicerates like spiders or scorpions. And so, there are lots of different ways you can mold these things. But you still have to work with what you've been dealt. Exactly. You can't increase your hand in your lifetime.
Exactly.
Right.
But Stephen Jay Gould, I remember here, I just was looking for this and I found it, but he quotes in his book, just to recognize how big this book is, on page 1174, he quotes this study from 1999 where they pose a question. He says, why do animals take the forms they do and not others? Why are all land vertebrates tetrapods except for cases of secondary loss, for example, snakes? While none have 6, 8, or many legs? Why is the situation precisely reversed for land arthropods? In general, why are there certain areas of multicellular morphal spaces densely populated with many representative species, while other areas apparently characterizing viable designs are unoccupied by an extinct animals. So he basically, getting back to my main point, it seems like within these specific trajectories, they're still trying to stick to a basic structure, even though that there can be variation within that, though.
Sure, that's more evolutionary constraints, though, rather than structuralist constraints. It would seem
that's not a difference, though. We're not distinct. We're not saying that they're non-evolutionary constraints, though. I wouldn't.
Oh no, I agree with that. I'm just saying that it doesn't seem to really push me towards a structuralism. It just seems like, okay, well, that's kind of what we recognize that. It's like, obviously the universal acid idea was wrong and we've moved past it.
Mm-hmm.
But does that get us towards structuralism? I don't feel that it does. I just think that it's more towards there are evolutionary constraints because you have certain Hox genes. You're dealt your certain hand and you can only go down a certain path, barring, duplication or neo-functionalization or whatever.
Well, I think maybe our definitions of structuralism are different, because I think
perhaps they are.
You're defining structuralism as something that I'm not. I mean, one of my understandings of structuralism is just basically starting with an extended evolutionary theory, or synthesis, I guess would be a better way to put it. Okay. So, I was talking to Sigard about this. He sent me one of his papers on it, but I mean, he goes in, it's called New Ideas in Evolutionary Biology, and he just talks about the different areas in which we're finding more, constraints or mechanisms that could cause evolution. Mm-hmm. And so, we kind of start from there, and then from that point, it might just be more philosophical ways to look at that. So if we have all these different constraints, external and internal, when an organism building on its own Hox genes enters into a new environment, it's still going to be constrained by that environment to go down a certain trajectory. And so if you have internal constraints, if you have positive external constraints, basically I'm not positing anything outside of what we would already expect within evolution. Structuralists, again, we don't disagree with functionalists. We don't disagree with a lot of stuff you say. We just are trying to say, well, if we get all of this together and we look at the big picture, it's hard to deny that it would be kind of similar to the periodic table in how it's sort of constrained by the laws of physics.
And see, I would disagree with that point, because what we define as what the elements of the different animal body plan or organismal body plans would be is, I mean, we can already see that that's highly variable, but it is still at its base built on historically contingent mutations, because these are the mutations and recombination are the backbone of variation, right? We get genetic variation from these events, which may or may not happen, right? And so that's why I would say, okay, well, you only get an arthropod, you only get a vertebrate because you have these certain genes which are specifying certain functions, and these certain genes were in certain environments.
That's not necessarily the case as much as it used to be. I mean, there's a lot of reworking in the role.
Can you give me an example?
Sure. Let me get a paper right here. It's called A Regulation of Ribosomal DNA Amplification by the TOR Pathway. And so one of the things I note is that a lot of what we see within genes when we're starting to study them is that to get from point A to point B, that is, the protein or the function, there are multiple different ways within the genes. So they say we tend to think of our genome as an unchanging store of information. However, recent evidence suggests that genomes vary between different cells in the same organism. This demonstrates that not all genome changes occur at random, and that cells possess specific mechanisms to optimize their genome in response to the environment.
Oh, well, I mean,
that's what I'm getting at. It's just they'll optimize their certain mechanisms to respond to the environment, but the environment then is sort of shaping them in a certain way, and that's sort of creating a certain channel for them to go along.
Well, I mean, in some cases, I think we've known that's true for decades. I mean, look at
Barbara McClintock, the first one to bring it up.
Stem cells, for instance. Why are we after totipotent stem cells as opposed to pluripotent or multipotent stem cells? Well, because they have the most potential for what they can become, right? Because the cells, once you have your totipotent stem cells, which in embryo, and then as you grow, they become, you develop your pluripotent stem cells and then your multipotent cells. And so because the cells are editing, okay, what do we need to turn on? What do we need to turn off? What are we regulating, right? And so again, I would say, okay, fine, that's fairly, that's fairly normal evolution. That's like you learn about that kind of stuff in like high school, I think, or maybe college. But again, not sure I would say that's when I think structuralism. I do think about the periodic table, because I remember that analogy from your video. I do specifically remember that one. But that one makes me very uneasy. That analogy does, because it sounds, when Michael Denton in particular brings it up, he brings up his types, because he's got his whole typology thing. If I remember correctly, he refers to them as discontinuous types.
Maybe I couldn't.
I remember reading that in, because I was thumbing through the first few pages of Evolution Still a Theory in Crisis. Which, thank you again so much for that. I really do appreciate it. I do it.
Oh, it's just saying you're welcome. That's all.
Oh, okay. So I was kind of thumbing through it, and he says there are these discontinuous types, and I do you agree that there are types? Because when I hear that, that gets my creationist sensors tingling, because that sounds eerily like baraminology.
Right. And I don't know if I would agree with him based on what I'm kind of getting with you on that. I think, again, as I said earlier, he's more very much extreme. He's more towards like Darcy Thompson's, end of it all. But no, what I was getting more about is what, Dennis Noble has been trying to bring more attention to, is this idea that, there is randomness within mutations, but a lot of those, it's not so much this idea that it just is luck. A lot of the times of what some of these recent studies have shown. So for example, like the one I mentioned, and also another study from 2007, alternative routes and mutational robustness and complex regulatory networks. I mean, what they're noting is a lot of cells or organisms sort of harnessing randomness to create certain changes, going back to what Barbara McClintock was trying to get
at. Like in immune responses.
Exactly. Yeah, exactly. That's actually one of the examples they use, is that it's not so much, a contingent, we just happened to fall upon the right thing. It was that the cells or the different organisms were trying. The example I remember hearing is sort of like a crank, gambling machine. You spin and you get a lemon. Okay, well, you can hold that one lemon, you can put a couple more quarters in and hope to get the other wheels to get 3 lemons to line up. So they're spinning randomness and hopefully trying to get a sort of positive outcome. And a lot of the studies lately have been sort of showing that kind of idea seems to be coming out, is that mutation, it's not so much like a random contingent history, but you can see that cells can use this randomness to harness certain outcomes.
Yes and no. What you're referring to is evolvability.
True.
There are like HIV is a very good example of something with high evolvability, because it's changing itself, or the generations are changing a lot as it's going, which is why it's so hard to eradicate, because it's in a person, because it's changing so much. The genetic makeup of it is changing extremely rapidly. And so that you're right, that sort of thing is very new. That's a very cutting edge stuff. That's in some cases, though. If I were to look at like the history of, and I think it certainly applies in some cases, like look at some groups of organisms are very prolific, whereas others are not. It's like, well, why is that? Is that just because they live in an environment, they live in a certain environment, or is it because their genetics is predisposing them to be better at adapting, right? And I would agree that that's a very interesting, very thought-provoking line of research. But I don't think of that in terms of sort of, in most cases, in sort of long-term evolutionary strategies, especially when I read, like I've been reading a lot of protist literature recently. The eukaryotic protists are, they talk about like, okay, you have there's an endosymbiotic event, which also is a very contingent interaction. And so you've got this endosymbiotic event, and then you've got these mutations that occur later, these losses, these gains, those sorts of things. And so it's all putting it in terms of historical contingency. Evolvability probably does play a role. How big of a role? I don't know. I think it'd be interesting to find out.
Well, I think I agree that going back to the stuff I was talking about earlier, I agree it only happens in some cases, but that's one of the main things that, people towards the structuralist end kind of get at. It's not one driving force. It's going to be a multi-layered, extended synthesis of different elements that are going to be contributing here and there. Like, of course, we have, horizontal gene transfer, for example. It's going to be different things, building into the things getting built up. But I mean, ultimately, though, on the larger picture, a lot of it is coming from different constraints within nature, some internal, some external, some negative, and some positive. So I think one of the things you get at is when what structuralists are trying to note is that we, I don't know if I feel like I've been saying this too much, so I apologize if I keep repeating myself, but it's like,
oh no, you're fine. We've got like 30 people listening. They love it. Everyone loves it.
Oh, good. Yeah. But in the extended picture, in the whole picture, ultimately, though, what you're going to get is you're going to get constraints from nature that are just going to be sort of like guiding. I hate using those type of words, but, I guess it's not too bad because Gould will use these words in his books, but sort of directing or guiding evolution in a certain way. So like Gould asks a very simple question. So like, if natural selection favored all of these traits as conjoined enhancers of essential stability, wouldn't its action be greatly aided by an internal mechanism that happened to bias variations in these directions or to forge correlations among these jointly beneficial characters? So he's basically just saying that it would sort of help an organism if it did have these sort of constraints that sort of guided in a certain direction.
I think maybe this might be another point of agreement. I think that, I don't know, it seems from what we've been discussing that I think it seems from what I'm hearing that Conway Morris is kind of leaning into, he thinks this is what the conclusion is going to be. Because I'm looking at this from, I really love evolutionary biology. That's kind of my main thing. That's like, I built my whole channel on it. And so from what I can see, from what I have read, and I've read a bit of Gould, but not a whole lot. But from what I have read of him and of evolutionary biology in general, I just don't see the push towards we should be able to predict these periodic table of forms. I've never seen that really posited. I think it seems to me to be a bit of a stretch of the evidence that we currently have. Sure, there's evolvability. Sure, there are phylogenetic constraints, things like that. But it doesn't seem to me that those are constraining enough or pushing organisms in a direction enough that we should be able to predict body plans, for instance. And that's my main...
I think I would try to come with you part of the way there. And what I would say, though, is like, yeah, I don't think we're going to get... It depends on how much degree we could predict, I guess you could say. Like, I think Morris gets taken out of context sometimes because he admits, it's not... It doesn't have to be exactly the same thing that we have.
Oh, absolutely. Yeah.
So, I think, one of the things I will say is like Life Solutions, he does go on some weird esoteric stories, but I think his later book, The Runes of Evolution, is a far more stronger case, and he really harkens in on a lot of the evidence for these trajectories and these certain paths that have to come about. Like he's got a whole chapter on mammalian features that have evolved multiple times or that have been sort of like shown to be almost positively constrained in certain ways. So I would kind of agree with you to an extent in that, yeah, I can kind of see where you're coming at. We are not going to necessarily get the exact same forms. And I'm only using the periodic table as like an analogy. I don't really think there is a periodic table of forms. I just would basically say, but at the same time, though, there are definitely very obvious positive constraints internally and externally, which are going to push organisms in a certain way. And if I could just sum it up in a nutshell, it's like if you're going to have an organism that's going to enter a certain ecological niche, it's obviously going to have to change in certain ways to fit that ecological niche, almost like water going into a vase. It's got to meet the shape required by the environment. And so that's kind of what Morris is really trying to get at, is that ultimately, though, there will be a certain demand from the environment on the organism, and that can cause positive constraints.
Let me see if I can summarize my position in an example. Okay. Think of you're familiar with the ceratopsians, like Triceratops and its relatives. Okay, so you have Triceratops and you have a bison, a modern American bison. you would look at both of these and say, okay, well, these are both these different lineages have converged on large herbivorous animals, or large herbivorous amniotes, right? It's like, yes, I would say that's convergent evolution, but I don't think that really speaks to the phylogenetic constraints necessarily, because they both came from small. Well, for one thing, these are both coming at it from completely different directions. You've got, well, both of their ancestors are relatively small, but the bison's ancestors are these small deer-like animals, where small quadrupedal deer-like animals, whereas the Triceratops ancestors are these small bipedal herbivores. But the ancestors of both went in a variety of different directions. Yes, you got Triceratops and you got buffalo from these guys, but you also got a smattering of other forms. You got, on the ceratopsian side, you got Protoceratops, which is little and no horns. Then you got Triceratops, which is big with 3 horns. As for the buffalo, their ancestors produced giraffes, hippos, buffalo, all of these equally, even whales, because they're all artiodactyls. So
but wouldn't those be different ecological niches they're all trying to fit in? I mean, obviously with whales, I mean, it's not going to be in the same environment as Triceratops or buffalo.
Right. And so it's that I would say that, like, the Triceratops and the buffalo converged on this form, but I wouldn't say that speaks to the process of evolution. It seems more that it's just convenient, or it's helpful for animals to get larger in, like, grasslands, for instance, because it helps you be bigger than the predators.
Yeah.
Right.
Yeah.
So I wouldn't say that's. Sorry, go ahead.
Oh, sorry, I didn't mean to interrupt you. But I think honestly, we are agreeing on a lot of things. We're just looking at it from like just different lenses, because like as you were just kind of going on, it's like the organism has to sort of get bigger if it's going to survive in those grasslands. Well, yeah, that's a positive constraint from the environment, and that's all I was trying to get at.
Mm-hmm. And I do agree that there are some, like I said, or maybe I think it was like you said, we're disagreeing on the size of the pipe.
Exactly. Yeah, I think that's basically it.
That should be I should put that in the description. Memorable quote: "We're disagreeing on the size of the pipe." Okay. I think I'm fairly satisfied by what I've heard so far. It's been just at an hour. Is there anything else that you want to say?
If anybody or you are interested, I have a lot of ebooks. I also have a lot of hard copies because I'm old and my eyes hurt when I read a screen too long. But if anybody wants a lot of the copies of the papers or the books I've cited, I have a whole bunch. Anyone can email me. So if you want like Rudolf Raff's book, The Shape of Life, or The Deep Structure of Biology, The Ruins of Evolution, I even have some of Michael Denton's books. A lot of the papers I cited I still have. So if anybody wants any of that, I can give them to you and take a look. There's a good paper. If you kind of want to get kind of a general idea of what I'm basically arguing, I think a paper I just read today, because Seigart just sent it to me, The New Ideas in Evolutionary Biology, I think it's really well articulated. He goes into if you're unexpecting it, he goes into a little bit of how this can correlate with Christian doctrine. But most of the paper is built on just explaining the extended synthesis and different positive constraints within evolution. So if anybody's interested, I can always send resources out quite easily.
Okay. Well, that's awesome. All right. Well, I do want to say thank you for coming on, and thank you everybody for watching. You're welcome, in the future if you ever want to come back on. So
yeah, no, thanks. I appreciate it.
If you ever want to wax phylogenetic about anything again, because that's my whole shtick, right? So anyways, all right. Well, thank you everybody for coming, and I guess we will see you next time. Bye.